So in this section, we're going to talk about something called the activity series. And this is just a way of sorting elements based on how easily they react with others. Some elements, such as gold, silver, copper, platinum, they do not react at all. You could go to a copper mine and find pure copper. Back in the 1800s in the Yukon, when the gold mining rush was in full swing, miners would actually go and they would actually find actual gold nuggets. Pure solid gold. Other elements, on the other hand, they react so easily that you would never find them as a pure element in nature. Sodium is one. If you look on YouTube and you search for sodium and water, what happens as soon as sodium is exposed to water, it starts bubbling. It actually reacts with the water and splits the water into its hydrogen and its oxygen gas molecules, and the reaction is so fierce that it actually will light them on fire and it can explode. So you'll never find pure sodium in nature because it's already reacted with any water that it's been exposed to, even water vapor in the air. But the activity series, what it does is it lets us rank metals specifically in order of how easily they react. Now I've got it listed here. It's kind of blurry, it's kind of small, but it is in the data booklet, much easier to read. Basically what this is saying is, will a metal displace or will it push out another element from a compound in a chemical reaction? So the general rule is if a metal, the actual metal, lone metal by itself, has a higher activity, or if it's higher on the table than the metal in the compound, then that reaction will happen. So you'll see a set of reactions that may or may not happen. Your job is to determine whether they will or not. So, in A here, if this reaction is going to happen, the silver metal that is by itself would have to be above potassium in order to make this reaction happen. So looking back, I'll just flip back quickly. Silver is near the bottom of the list. Potassium is actually second from the top, so silver is not above potassium, it's below potassium. Silver will not be able to replace potassium in this reaction, so this reaction will not happen. And RXN is just the standard abbreviation for reaction. Same idea in B. Zinc would have to be above silver if this reaction was to happen. Take a look at the activity series, and zinc is actually above silver, so this reaction will actually happen. In C, aluminum would have to be above, well, we don't have a metal in the compound, but we have hydrogen, which can behave as a metal in some ways. Needless to say, if this reaction is going to happen, aluminum must be above hydrogen, and it is, so we have a reaction. D, lithium would have to be above hydrogen to make this reaction happen. It is. E, for this reaction to happen, copper would have to be above iron. Copper is below iron, so this reaction will not happen. F, for this reaction to happen, sodium would have to be above hydrogen, which it is. G, iron would have to be above lead, and it is. H, copper would have to be above hydrogen. It is not, so no reaction. In I, copper would have to be above aluminum. It is not, so no reaction. J, aluminum would have to be above lead, which it is, so this reaction happens. K, iron would have to be above silver, which it is, so this reaction will happen. And L, aluminum would have to be above copper, which it is, so this final reaction will also happen.